Welcome to Brain Vision.
So in this problem, we have some diver that is on the end of a springboard. He's said to weigh 582 newtons. The springboard is uniform of 142 newtons. And that there is two supports, one on the end and one some distance, 1.55 meters from the end, and that the overall springboard is 4.48 meters long. So we want to draw a free body diagram. So the first thing we should do is put some axes somewhere, and we can pick the end of the board as such, but many other places could be convenient. And we want to draw the body as simply as possible. It's a board, and we can't use a point like some other free body diagrams because we have forces at different distances. And we want to put all of the forces as they act. 142 newtons. We know that that is 1/2 of the length, which 1/2 of 4.48 is 2.24. We have the weight of the diver, 582 newtons. And then the two reaction supports, we will call them left and right, some 1.55 meters apart. And we can also put in our axis again. So this is the free body diagram. What we've done is freed the body. So we've taken these external supports and reduced them to the forces that apply onto our body in question, which is the board. And with this, we can solve for the reaction forces. So we're saying that this is in equilibrium, which means the sum of moments is equal to 0, as well as the sum of forces. So we'll start with the sum of moments about the left reaction. We'll pick clockwise to be positive for this equation, because the right, if we tend to extend that, would rotate counterclockwise about point L. We'll say that it is negative. A moment is a force times the distance. So we have our negative times the right reaction and the distance, 1.55 meters. The other two forces, though, tend to rotate clockwise, so they stay positive. Plus 142 times its distance, 2.24 meters. And 582 times the 4.48. This is all equal to 0. We can directly solve that for R to be 1,887 newtons. From that, we know R. We can use sum of forces in the y direction to find L. L and R will be positive because they're in the positive direction. 142 and 582 will be negative. Sum forces in the y is equal to 0. As we talked about, L and R, 1887, are positive, and the two applieds are negative. It's equal to 0. And this works out to L being negative 1163 newtons. So this is okay. All it means is that we assumed a direction here and it's wrong. It's actually downward. Now that does kind of make sense because there's a big moment here rotating clockwise. And so we need this left reaction to make the clock counterclockwise moment to fix it. But that is this problem. We've looked at making a diagram of the problem, making a free body diagram, as well as using static equilibrium to find reaction forces.